Hey guys, I'd like to um, make it a little bit more clear what's happening in the CPU and how it handles instructions. So before we talk about how it handles instructions, I just want to give you a little bit better of an understanding of the CPU itself. So this diagram right here is a diagram of the CPU. And first I want to say that the CPU has three pockets. So the three pockets are A, D, and PC. And if you remember from way back earlier, I used an analogy to describe the computer's memory, um, all the way up here, where I said that there's different types of memory. There's the drawers. The drawers are analogous to RAM. The warehouse is analogous to a hard drive, and the file clerk has pockets, which are a very fast and small type of memory. So the CPU that we're building has three pockets. And those three pockets are registers A, D, and PC. So I'll show you that. So A, D, and PC are the three pockets that, store one card, let's say. So pocket D is just there to store a card, but pockets A and PC have a little bit of a different purpose. The card that they store is going to point to something in RAM. So, the card they store is just a pointer. It's not really like carrying data. It's pointing to other data. So let me show you that. A gets funneled all the way this way and is outputted as address M. So we can see on this diagram, address M is pointing to one of the registers in data memory, in RAM. And you can also see that the register that's being pointed to gets funneled through all the way over here and is fed back into the CPU as in M. So it's sort of like if we use the file system analogy, if the filing clerk has a drawer open and is looking at a card, and he uses the, pocket A to decide which card to look at. So again, CPU has address M that's pointing to something in data memory, and that's being fed back into the CPU, so the CPU can look at it. And I just want to go up back to the registers to show you that you need to point to something. Oh, it's further down, in order to see it. So where is it here? The RAM has all these different registers, and only one of them is outputted. So you need to point to the one that you're interested in, and that's this address input wires. So back over here, that's what address M is. It's pointing to one of the many registers in data memory. So let's just take a look back at this. A is the pocket that is pointing to one of the registers in data memory, and it does that, and then it gets funneled all the way back in through in M. Okay, so something similar is happening with the PC pocket. It's pointing to one of the registers in instruction memory. So you see that PC is being outputted over here, and you can see in this diagram, PC is going to point to something in instruction memory, and then whatever register it's pointing to has its contents outputted and fed back into the CPU. Okay, so we've got these two pockets that are basically pointing to something here and pointing to something here. So the CPU is looking at something in data memory, and it's looking at an instruction. And now that we understand that, let's start to talk about how the CPU reads an instruction and what it does with the instruction. So first, let's say that the instruction is 16 wires, and the first thing that happens when the instruction goes into the CPU when it goes into this dotted area over here, it gets split up into different components. And I show that over here. The components are A, C1 through C6, D1, D2, D3, J. You can see that over here. So there are 16 wires, and there's different groups of wires. There's the C's, the D's, the J's, the A, and then these 3 wires don't get used. So the first thing that happens, again, it gets split up into these different components, and really there's like a wire that goes from here all the way over here. But in this diagram, they just use the C icon to keep it more clean. But really, there's a wire that's coming all the way around like this and being fed into here. And like the C, there's a wire that comes all the way over here and is fed into the ALU. So hopefully that makes the diagram a little bit more clear. The first time I looked at the diagram with all the C's, like I didn't know what the C's meant. Okay, so let's start talking about what the CPU does with this instruction. So one thing that it does is that it decides whether to send an A or an M into the ALU. The M is is whatever register is being looked at here. It's getting fed in this way. We call that M. So you can see this MUX chip, the A over here is going to decide which one of these inputs it's going to funnel along. That's how the MUX works, the multiplexer. So depending on whether A is on or off, it's going to either send A into the ALU or M into the ALU. So that's one thing that the instruction is used for, to decide whether to send A or M to the ALU. The second thing the instruction is used for, which may be the most important, is to decide what computation to perform. So you can see that the instruction gets broken down into, one of the components is C1 through C6, and that gets fed into the ALU. And if we go back up to the ALU diagram, we can see that those 6 wires are going to tell the ALU what to do. So these 6 wires over here, that's C1 through C6, that's going to tell the ALU what to do. And we saw this earlier in this diagram, where depending on which of the wires are on or off, it's going to end up doing one of these different computations, like x minus 1 or y minus x, whatever. Depending on the ones that are on, it's going to perform a certain computation. So if we go back down, we can see that part of the instruction, C1 through C6, get fed in here, and they tell the ALU what to do. And let's take a look at this diagram here. This shows that when C1 through C6 is, let's say, 0, 0, 0, 0, 1, 0, it's either going to be D plus A or D plus M. And that's going to depend whether A is on or off. If A is on, it's going to say to feed M into the ALU. If A is off, it's going to be feeding A into the ALU. So that's an example of how the instruction is telling the ALU what computation to perform. Okay, so far we sort of have 1/2 things that the instruction is being used for, to feed A or M into the ALU and to perform a certain computation. So once we perform the computation, the next step is to decide what are we going to do with the result. And we can see that the result is being fed into multiple places. It's being, fed out of the CPU chip as out M. It's being fed back into D. It's being fed back in all the way to A. So it's being, sent to these 3 different places. And, based on what the instruction says, the instruction might say, I want you to write the result of the computation back to A. I want you to write it back to D. Or maybe I want to write it into data memory. So if you remember back to the filing system analogy, the filing clerk can do three things. It can read, it can write, and it can do computations. It can read from a card, it can write on a card, or it can do computations. That's it. There's no magic, weird, high-level things that a computer can do. It can only do those three simple things. So here we're talking about the writing on a card. That's one of the three things it can do. So it can either write on D, write on A, or write on data memory. And the thing that determines, how the instruction tells the CPU what to do is with these D wires. So if D1 is on, the output is getting fed back into A. If D1 is on, that acts as the load wire in this register, and it's going to load the result. It's going to load the result of the computation into A. And similar with D2, it's the load wire. So if it's on, it's going to load this input into D. And, it's the same thing with the data memory. D3, if D3 is on, write M is going to be on. So write M is going to be the load wire for this big RAM chip. And if the load wire is on, it's going to store the result of out M into the register that's being pointed to by address M. Let's look back up at the RAM so we can understand that a little bit better. So the address is going to point to one of these registers. The in, this is the result of the ALU's computation. And if the load wire is on, this is going to get written to the register that's being pointed to by the address. So maybe the address is pointing to register 2, and the input is all ones. So that means if the load wire is on, all ones are going to be written to register 2. Okay, so let's go back to the CPU diagram. So we talked about how the CPU is going to read. It's reading from in M, and it's reading from the instruction. It's reading, it's reading a card, like a filing clerk, taking out a card and reading it. We talked about how it's got these pockets. We talked about how it performs a computation, and then we talked about how it's going to write the result of the computation to, one of the cards in here or outside of the chip. So finally, let's talk about the last thing that happens, and that's how it gets to its next instruction. So if you remember, PC is the chip that points to the current instruction. And normally what happens is PC just gets incremented at the end of the cycle. But alternatively, we could load the value of A onto PC. So A is being fed in as the input to this register. And if we want to load, the value of A on here, we'd have to set the load wire on. So that's one of the wires in the instruction, this J part. So if it's on, it's going to set the value of this chip to be A. So in that way, we can jump around between instructions instead of just going like 1, 2, 3, 4 in order. We can say like perform this computation, set the results to A, and then load that onto PC. So like if we want to, I don't know, maybe the result of the computation is 3040. So we write 3040 onto A, and then we set this load wire on. 3040 is being fed into the program counter, and if we set the load wire on, it's going to be written to the program counter. And then for the next instruction, 3040 gets outputted through that wire, and 3040 is, fed into the instruction memory, and it's going to point to register number 3040. So then the next cycle, the contents of that register are going to be fed into the CPU. And then, they're split up into their components, and they're used to do the next computation. So that's what's going on in the CPU. I know it's complicated. You don't really need to like memorize all that's happening with these wires, but hopefully this overview, showed you that it's not magic and gave you a pretty solid, like high level sense of what's going on. If you want to really, grasp this and study it deeper, I'd recommend going to Nanta Tetris. It's a great class, and if you go through their class, you'll have a even deeper understanding of how the CPU works.